All right, so we want to go over confidence intervals and hypothesis tests for differences between two population means. So we have covered confidence intervals and hypothesis tests for one population mean, an unknown population mean. We've covered confidence intervals and hypothesis tests for one population proportion. And now we want to look at finding confidence intervals and doing hypothesis tests concerning the difference between two population proportions, two unknown population proportions. What's the difference between the two? So first notation, we're going to let mu sub 1 and mu sub 2 be those unknown population means, 1 and 2, unknown population 1, unknown mean of population 2. X bar 1 and X bar 2 are the sample means that we get. Now also, I neglected to put these sample sizes in, right? So N1 and N2 are the sample sizes. Sample 1 and sample 2. Okay, sample 1 and sample 2, sizes N1 and N2. So N1 is sample size 1, N2 is sample size 2. X bar 1 is the sample mean we get from that sample size. Now, these don't have to be the same. We take a sample of size N1 from population 1, we get a mean and a standard deviation from the sample if we don't know the population standard deviation, similar to what we worked with earlier. X bar 2 is the sample mean from population 2. Now, again, these population standard deviations are going to be sometimes known, sometimes not. If we do know the sample standard deviations, then just like before, we use a z-test statistic and the standard normal table to come up with our probabilities. If we don't know the population standard deviations, we use the sample standard deviations, and then we go to a t statistic and t critical values for our confidence intervals. So that's all the data, right? Two populations, two population means, two sample means, two population standard deviations, two sample standard deviations. So when we're talking about confidence intervals, for the difference between two population means, they're going to take this form, one of these two forms, and depending on if we know the population standard deviations. If we do know those population standard deviations, then this is going to be the form of our confidence interval. We will do some videos of examples of each one of these cases. In this video, I'm just going over the notation and the formulas. So this is our point estimate for the difference between the two populations. This is the center of our confidence interval, the difference between the two sample means. That's going to be our center of the confidence interval. And then we're going to go out our margin of error. Remember, our margin of error. And if we know the sigmas, we use a z critical value, our usual z critical values for certain levels of confidence. We've gone over that. And this now becomes the standard error of that sampling distribution of the difference of two population means. So it's just, it looks a little more complicated, but it's just numbers. You're just plugging numbers in. You have a calculator, so it shouldn't be that difficult. This is the form of that standard error. The population standard deviation squared over the first sample size, the second population standard deviation squared over the second sample size, square root of all that. We multiply that by z critical, and we get our confidence interval for the difference between two population means when sigmas are known. If we don't know sigma, then it has the same general formula, except now we're using a t critical value instead of a z critical value. And instead of those population standard deviations here and here being squared, we have these sample standard deviations being squared here and here. Otherwise, same form. Center of the confidence interval is our point estimate for the difference between those two unknown population means. And then our margin of error. In this case, we use a t critical value and the s's instead of the sigmas. All right, so that's for confidence intervals. Again, we'll do some examples of that to show you, to put some numbers into these formulas. When we talk about hypothesis tests, again, very similar to what we talked about for a single mean. Only thing that changes is the form of our z statistic. If the sigmas are known, we're going to use a z statistic. And it has that same general form as all our other z statistics. Point estimate minus the hypothesized difference. Now, our hypothesized difference is going to be 0. We're going to be going into the test thinking there is no difference between those two population means. That's always going to be our null hypothesis, that there is no difference. And then our alternative is we're either going to look at a one-sided alternative to the right, a one-sided alternative to the left, or a two-sided alternative. But the null hypothesis is always that there is no difference. So the difference between the two sample means minus 0. You don't really need to show the 0. I just want to show it to kind of placehold. And then divided by that standard error of the distribution of the difference of two means when sigma is known. The square root of the sum of these two ratios, the standard deviation from the first population squared over the first sample size, standard deviation of the second population squared over the second sample size. And that's our z statistic. Other than that, everything's the same. Set up the null hypothesis, and again, we'll do examples of this to show exactly how I want to see your work done. Form the hypothesis in step 1, form the test statistic in test 2, find the p-value in step 3, make a conclusion. All those 4 steps are still valid with these hypothesis tests for the differences between two population means. And similarly, if we don't know the sigmas, we use a t statistic. And again, the only thing that changes is you're substituting the s values here and here, whereas we use the sigma values here and here. All right, so confidence interval for the difference between two population means when sigma is known. Confidence interval for the difference between two means when sigmas are unknown. Hypothesis test for the difference between two population means when the sigma is known, a z statistic, and a standard normal table. Population standard deviations unknown. We use a t statistic and the student's t distribution. And another thing, when we do this, the degrees of freedom for this test are going to be 1 less than the smaller sample size. All right, so whatever the smaller sample size is, you subtract 1, and that's going to be your degrees of freedom that you use for the t distribution when you look up the probabilities. All right, so degrees of freedom is the lesser of n1 or n2 minus 1. All right, so the lesser of the two sample sizes minus 1, that's going to give us our degrees of freedom. All right, so we will do a few examples in future videos dealing with these situations, but this video is just to go over the notation. Thank you.